Okay, let's do one combined gas law equation. If you know how to do one combined, you can do all the questions in initial and final gas law problems. So you are using this equation which is given on your formula sheet for combined gas equation. But there are all variables varying here, but sometimes you don't have all the variable. Say for example, if you have this is the whole combined gas equation. If you have only 3 variables, like therefore there is no number of moles, you are just removing that. So your equation will be P1V1 over N1, sorry, P1V1 over T1 is equal to P2V2 over T2. And if there is no T, then you are erasing T, so you will get the Boyle's law equation. So that's why this is useful. All the formulas are here, okay? Let's do this question. In this question, it says a sample of gas has a volume of this. So I'm going to write that is the initial volume, which is 25.5 liter. And ATM, that is a unit of pressure, which is 17.4 ATM. Okay. Then I have degrees Celsius. I know that that's temperature. So I'm going to convert that into Kelvin. So remember, we have to do calculations only in Kelvin, and the conversion is also given to you. Okay, so you are adding 273 to degrees Celsius and you will get 300 Kelvin. And I would always keep the same significant digits irrespective of the rules, because I was looking only these numbers for deciding the significant rule. Okay, now it says what volume, that means you are going to find the second volume if the gas changes to STP condition. Okay, so if you don't know what is STP means, which is standard temperature and pressure, the temperature will be 0 degrees Celsius and pressure will be 1 atm. So that is the second condition. So temperature changes to 0 degrees Celsius. We know that in Kelvin is 273. And pressure, which is 1 atm. And remember, if the initial pressure is in kPa, you can pick this value, any values. These are all standard values. Okay, so since this question is given in atm, I'm going to pick in value in atm. Okay, so these are the values listed, and you guys going to find the volume. Can you do a prediction here? So I'm going to predict like this. There's a pressure which is 17.4 and it is decreased to 1 atm. So when pressure is decreasing, that means pressure is decreasing, that means volume will increase. That is my prediction. Let's see how it will go. It's based on Charles' law prediction, but temperature is also matter, but there is only a little bit change, so only pressure is the predominant factor. Okay, I have P1, V1 and T1 and P2, V2 and T2, so I'm going to pick this equation and just without N. So my equation, my formula will be P1, V1 over N1 is equal to P2, V2 over N2. Sorry, we don't have number of moles, so we have to write T1 and T2. P1, V1 over T1 is equal to P2, V2 over T2. Okay, now you are aligned the volume, which is V2. So you are going to multiply P1, V1 over T2 divided by P2 times T1. Okay, so the P1 is 17.4 atm. V1 is 25.5 liter. T2 is 273 Kelvin. Then divided by P2, which is 1 atm, times T1, which is 300 Kelvin. So you are multiplying everything and dividing. Okay. You may use, if it is a different number, you may need to use a parenthesis. Okay, so answer is 404 liter. We need the answer in 3 sigfic, and you can see ATM and NTM cancel out, Kelvin and cancel out. So only thing remaining is liter. So your final volume is 404 liter. It is matching with our prediction because it was 25.5 liter at the beginning and now it is 404. That's it.